Hi everyone, I'm Tom Sadler. I'm a software engineering team lead in BBC iPlayer and Sounds and a board member of the InnerSource Commons Foundation. My co-presenter Steph Egan is a principal software engineer, and we are both leaders on InnerSource and continuous delivery practices within iPlayer and Sounds and across the wider BBC. The BBC, the British Broadcasting Corporation, is the UK's public service broadcaster, and iPlayer and Sounds are its video and audio streaming services. So we previously did a version of this talk entitled InnerSource and DevOps like chips and gravy. Continuous delivery is a key part of DevOps, and we believe these practices work extremely well together. For anyone not from the north of England or from Canada, we'd highly recommend you try chips and gravy, and we also recommend you try continuous delivery with InnerSource. So today we're going to talk about what is InnerSource firstly. We're going to cover some of the BBC iPlayer and Sounds continuous delivery journey, how inner sourcing continuous delivery tooling has helped us, and how continuous delivery has benefited our InnerSource projects. So, what is InnerSource? InnerSource is the use of open source best practices for software development within the confines of an organisation. So what this kind of looks like in practice is, much like with open source, you have contributors making pull requests into a software project and the trusted committers reviewing, feeding back and merging these in.
Next, I'm going to talk about our continuous delivery journey so far. So the BBC has moved to a DevOps model when we moved over into using cloud services. And suddenly all our teams had the freedom, but also more importantly, the responsibility to control not just our applications, but also the infrastructure that they were built on. And we've spent the last 5 years working out what that means. Teams manage their own CI/CD infrastructure, how their applications are deployed, what they're deployed on, and they support the whole application out of hours. What resulted was hundreds of ways of building and deploying applications. My team, Delivery Engineering, was created in response to that. How do we help these teams move faster and have better engineering practices overall? We're part of a group of support teams who help in all areas of DevOps. You could maybe call us site reliability engineering if you put all of those teams together. Delivery engineering has been around for almost 3 years now, and we use a couple of techniques to help teams in iPlayer and Sounds. First, we build tooling that we see solves problems that a lot of teams are having. And secondly, our subject matter experts like myself work directly with teams in a consulting capacity to help them achieve their goals. This can result in running workshops, pairing alongside teams, sharing knowledge, and asking them hard questions about their processes and practices. One of our focuses has been on helping teams understand where they currently are, and we do this by helping make it easy to measure and use the 4 key metrics. If you haven't seen these before, they came out of a large amount of research by the DevOps Research and Assessment, or DORA, and you can read up on them in the State of DevOps reports or in the Accelerate book, which I would highly recommend. So those 4 key metrics are deployment frequency, change lead time, mean time to recovery, and failure rate. And I'm not going to go into the specifics of those today, but these measurements overall give an indication of how well your team is performing. And then we use these to reflect regularly on where we're at and how we want to improve. My team is there to support over 30 teams who work in the iPlayer and Sounds space and have influenced the way that these teams talk about their throughput and availability, and our tooling is used across the whole organization. The reason that this has been so successful, I believe, is because of 2 key practices that we held from the very beginning. First, we make our services as easy to use and integrate with as possible. This means removing as many barriers to entry as possible, often creating more work for ourselves so that other teams don't have to do it. One of our most popular services we provide, we called Proxy, and it's really simple. It just provides some authentication on top of S3. But this allows teams to make internal tooling easier, and everyone thinks it's great just because they don't have to talk to us before they install it. They can just use it. The second principle is that we aim to merge every PR that comes our way. Our tools have been built from the ground up with the expectation of contributors from outside our team. The way that we encourage that in a very disparate organization is mostly word of mouth and clear documentation. This builds up a reputation that we really care about the effort that other teams put in and are looking to support teams more overall. And this is not the expectation generally across our organization at the moment, so people find it quite refreshing.
So, as a customer of the delivery engineering teams, I've seen the benefit of continuous delivery tools being built in InnerSource from the ground up, and I've also seen the other side as my team maintains a shared continuous delivery pipeline. So, Deployment Tracker is one of the tools made by Delivery Engineering. This is a system which tracks iPlayer and Sound software deployments, and the data is used for measuring deployment frequency and lead time. This data can be used for other things. For example, there was an InnerSource contribution made to Deployment Tracker to integrate with our monitoring systems so that graphs could include annotations showing which component was deployed to what environment at what time. This example shows the launch time of our TV applications, and using the deployment annotations, we can easily see if a release has had an impact on this. Having this detailed understanding of how our software is behaving in production is exactly the type of things we need when we're continuously delivering software. This is a great example of an InnerSource contribution where the value added scales across the multitude of teams who are using it. So moving on to my experiences from the maintainer side, so I work on the iPlayer and Sound's connected TV applications, so connected TVs, smart TVs, set-top boxes, games consoles and other streamer devices. And these TV apps are composed of many shared libraries and are maintained by a number of teams with responsibilities split by functionality. For example, my team develops and maintains the initial application launch and user sign-in. So organisationally, it looks a little bit like this, where we have, in this kind of example, you've got the red team, the orange team, and the yellow team, and they own between them the shared application, the shared TV client, with then some upstream services that can be wholly owned by one team or another. So as I said, one of the things my team maintains is the shared CD pipeline for the connected TV applications and the supporting libraries. And having this shared pipeline means that apps and the shared libraries are truly continuously integrated and continuously deployed, with all teams working on the TV client taking end-to-end ownership of their code. Coming back to Deployment Tracker and its release annotations, the shared pipelines Deployment Tracker integration is an example of a classic InnerSource benefit. Many teams benefit from features added to the shared project, in this case the shared project being the pipeline. And allowing contributions to the pipeline unlocks many more opportunities, such as this work where the Operability Guild added telemetry around how long the pipeline is taking, and this is a sort of feature that might never have happened if we didn't allow contributions. So to summarise why we InnerSource the pipeline, product development teams can contribute to the infrastructure that releases their code. There's less demand on the pipeline owners, my team's time. Increases the reuse of continuous delivery infrastructure for common functions in the TV application space so that teams can spend more time on product development. Any features added benefit all adopters. And like with my previous example, certain functionality gets added that otherwise would never have been done.
So now I want to talk about why you should InnerSource your continuous delivery tooling. First up, continuous delivery is hard. Thinking about your application, its infrastructure, how you deploy it, all requires a lot of knowledge and experience to get right. And a 2 pizza-sized team, it just isn't doable sometimes. Building tooling that any team can use will mean that they can think a little bit less about these areas and accelerate them in their real focus, which is building great applications. Secondly, continuous delivery is a common problem. As I mentioned earlier, our hundreds of ways of deploying did have a lot of crossover, and teams are experiencing very similar problems. Solve the problem once and let everyone benefit. Yes, it's harder to do, but it helps those teams that would never really have had the time to flourish. It brings everyone up to the same level. As Tom showed earlier, Because we had everyone's deployment data in one place, we could start presenting that in a new way on our monitoring graphs, which was free for everyone. You could say this is why centralized ops teams existed in the first place, but hopefully this still gives the teams the benefits of DevOps: autonomy, responsibility, and ownership. Finally, continuous delivery is personal. Although there are lots of common problems, no one team works the same way. And I don't think that we should be forcing any team to work in a specific way. The tools my team builds have to deal with a lot of completely different ways of working. The change lead time for one team is not quite the same as another. InnerSource allows us to be open and honest about the figures we produce, but also allows teams to make things more accurate for themselves. If they need to cover a specific use case, they can. One example of this was a contribution to add time selection to our metrics viewing website. We'd written this off due to time constraints, but one team really wanted it, and they were able to contribute that feature, and now everybody benefits. So to summarize, why should you InnerSource your continuous delivery tooling? Teams can focus more on where their expertise is, building great applications. It brings everyone up to a base level of practice, irrelevant of their skill level, and teams can have more say in the direction of the tooling that they use.
So I talked before about our shared CI/CD pipeline and the benefits of it being InnerSource. Now I want to talk about how it and other DevOps practices we use actually make the TV client code better for InnerSourcing. So as a reminder, our TV apps are maintained by multiple teams with responsibilities shared by functional area, such as user sign-in, playback, or the home page. So over the years, we've gone through a fairly typical continuous delivery journey, moving from quarterly releases with on-premise infrastructure managed by a separate ops team to many releases a day deployed to our self-managed cloud infrastructure. As we decreased the amount of time it took to release changes, we found engineers were more willing to make InnerSource contributions. This is because a short, reliable deployment timescale gives contributors the confidence that their changes will make it to production in a timely fashion. We use branch-based development and discourage long-lived branches. This strikes a balance between being able to work autonomously on branch, but also practicing continuous integration. We implement continuous integration by having pipelines for each open pull request. This gives you high confidence in your work in progress, which is doubly important if your work in progress is an InnerSource contribution. And we have automated release notes, which are essential for our process. Teams can work autonomously within their ownership areas, but their work is automatically visible for other teams via the release notes without any additional overhead. And also make sure that contributors include relevant information in their pull requests. This two-way visibility is very helpful when working in InnerSource. Automated releases are enabled via structured versioning, labels on the pull request, and our pull request template. This enables the release generator to determine the version number, populate the release notes from the pull request body, signal whether the release includes any audience-facing changes, and includes a link to the Jira ticket. All this enables the transparency and visibility requirements of working InnerSource and is enforced by our GitHub setup with code owners and checks via the pull request pipeline. Code owners results in the relevant trusted committers being notified, and the pull request can't be merged until they've reviewed it. You can't merge unless the branch is up to date with master and has passed our automated tests, which reduces the risk of bugs being caused by conflicts across branches. And you can't merge unless the relevant labels are present and the pull request template has been filled out to enable the automated release notes. So this is the process when you're working on TV client, regardless of whether you're making an InnerSource contribution or working in your own area, the main difference being who does the code review. And the automated release notes enforce consistent visibility of work on TV client across the teams. This makes contributing to TV client seamless. This journey has been a great success for both continuous delivery and InnerSource. One of the ways we've measured this was through deployment frequency and lead time, which is 2 of the 4 DevOps key metrics. But these metrics are pertinent for InnerSource too, and suggest that InnerSource doesn't slow down development, and if anything, it actually speeds it up. So to summarise, why should you continuously deliver your InnerSource? It means that all teams have visibility of each other's work. It means that shared code is continuously integrated and deployed for all consumers. You're not leaving anyone behind. Quick, reliable deployment encourages InnerSource contributions, and continuous delivery gives confidence to potential adopters, contributors to your InnerSource project.
I hope that we've shown that both continuous delivery and InnerSource result in higher quality, better documented, better supported code. And I hope to leave you today looking to InnerSource your continuous delivery tooling by solving common problems once and self-serving your release software, and also to continuously deliver your InnerSource projects, make contributions seamless, and have confidence of stability in production. Just to finish off, wanted to put a couple of questions that we were thinking about after making this presentation. Initially, this presentation was pretty hard to make. Where are the boundaries between InnerSource and continuous delivery? Continuous delivery is considered best practice in most places, but perhaps wasn't a few years ago. 2016, the DevOps handbook came out. Should InnerSource be considered best practice as well? Thanks for listening.